Hello and welcome. Today we're going to continue building the pathlib deck for Python cards. Very quick intro. If you don't know Python cards, it is this tool I'm building, this project I'm building for learning Python using spaced repetition. That is, using this kind of flashcards in which you get a question, then you think about it, show the answer, and then you give feedback about whether you knew it, if it was easy, and so on. The easy cards, you will see them at longer intervals. The ones that are harder for you to learn, you will be reminded of them more often. So we're building this deck of cards. In fact, we don't have it as a deck. Let's add it. We will, of course, Python cards is public. You can visit it at python.cards, but we are working still on the development side. So here we can add a deck. Let's add this deck called pathlib in depth. Let's make it the first one, I guess. Is it ready? Is it free? Okay, let's save and continue editing, and let's see we see it in the pathlib in depth, 0 cards. I think we want to make this first because in the end, this is the first one we're building, right? So let's move nomenclature one step down. So we will have pathlib in depth, the first one. And then we'll have to add all the cards. So we, as I've mentioned in other videos, we need to work on adding all of these cards, which we have for now in Markdown. We will import them into this deck. So here, let's have this pathlib in depth, and let's have a short description, which we'll later edit, but we could say pathlib. Let's see. Are we processing Markdown here or not? No. The pathlib library, what is it good for? It's good for offers the most convenient way of managing files and file paths. Convenient. Also, so there's one thing that, so for some people, let me make a defense in defense of pathlib, right? So why am I working on pathlib? So pathlib is good for managing files. So if you want to change the suffix of a file, it has an easy function, right? With suffix. If you want to read a file, if you want to touch a file, which means creating it or modifying the time and so on, it is kind of convenient. But some people might think that this is like very stupid, right? So in the end, it's you could do it with OSPath, or you could do it somehow different. I mean, what's the big deal, right? But I have to say that I don't believe that. I think there's a very, very, very big deal. And this is because there's some kind of jobs that you need to do, programming or administering systems or whatever you're doing, which can be done using files. What do I mean with this? There's one kind of jobs. So some years ago, I did my PhD in the Barcelona Supercomputing Center, and I had to compute hundreds of thousands of jobs. These jobs were run in a supercomputer, and there are some fancy frameworks or some fancy libraries for managing like distributed tasks and so on. But there is one way of managing all of these jobs that is very simple, that is very old school, and that really, 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 really just works. And that is using the file system. Of course, you need to have some kind of, distributed file system that is very big and that can manage a lot of files and whatnot. But the abstraction that the Unix guys thought of having these directories, files, modify time, and so on, that is huge. And pathlib just gives you a very, very good abstraction to handle these kind of things. So what do I mean with this? Imagine you have this processing pipeline and you have some input and you have some output, but then you have some intermediate steps that may take a long time to compute, and you want to run them in parallel, or you want to know if a job started so you're not processing it twice, and so on. And there's one easy way of doing this, which is just managing the files on disk. So you check if a file exists. So the inputs, you create some files for the inputs. Then you check if these inputs exist. Then you start computing something. And this, when you start this computation, you create another file, like a temporary file on the disk. Then when the temporary file is finished, then you create like the output file. And then you can do this as a pipeline with many steps and so on. Another case where I use this is for processing maps. So in my previous startup, we were managing a lot of map data. Imagine OpenStreetMap, and we were managing a lot of public transit data. So there are some feeds where the public transit times are specified and so on. So we had this pipeline that, for example, splitted maps for different areas, or it joined public transit data from different feeds for a given area, or it sanitized this public transit data, and so on. All of this was entirely managed by a very, very short Python script that did a lot of things and was using pathlib as the way of managing all these files. So, well, this is kind of in defense of pathlib, right? So you might think that this is, I mean, why am I learning? Or why do I care for learning all of these parent, whatever? What is this useful for, right? So it is useful. It's not like you need to remember this. If you did not remember this, well, you could search for it and you would find it, right? But just knowing this just takes you one step closer to the implementation of one of these kind of jobs, right? So if you know how to manage this very well, then you are very close to having this kind of very neat processing that is very robust and that is very easy to understand by someone who comes in and so on. So, well, that is my defense of pathlib. That's why I think it's important, because files and directories just hold a lot of power. And it's very easy nowadays to say, oh, no, we put this into a MongoDB, or of course you want structured data or whatever. The cloud, sure. But in the end, you will be doing some processing in a machine and you will need these directories. And then if you know how to manage files, you are in a much better position to do it. So, well, that's my defense of pathlib. So here, my description for pathlib in depth. The file library offers the most convenient way of managing files and file paths in Python. Learn its full power and master its API. Whatever. Just some description that I will probably change some other day. Okay. So yesterday we left it in an interesting place. So if you watch my previous video, at the end, I also wrote a blog post about this. In the end, I was a bit confused, and you will see this. Well, there's this funny moment that I link, in which this is where I was. So if we run this code in Python 3.11, we're basically creating a pure path of a pattern, and there, which is wildcard.py, and we're trying to match this, and this fails, okay, which is very interesting. Then, if instead of doing this with a pattern, you would do this directly with a string, this works. So this is something that in the documentation, sorry, I think, well, I'll make myself smaller. I don't know if that was already done. So in the documentation, it doesn't say that in 3.12 the case-sensitive parameter was added. Okay, that's fine, but it's not only that this was added. In 3.12, they added something else. So they added the ability, let's use Python 3.12, And now let's run this, the same thing. And now this works. So they added the ability of matching a path against another path. And this is something that is missing from the documentation. So I created an issue in the CPython project. This is my first issue, my first contribution ever. I explained this issue. Someone agreed to it. Oh, let's see this. And someone created a pull request for this thing. Let's see. Let's see. I haven't checked what is the file change. Let me see. Version change 3.12 accepts another path object. I mean, I don't like this sentence. Like, this is a very, I would say, accepts a path object as the pattern, I would say. Access path object accepts another path object. I don't know. I would change this. Maybe I will comment to this pull request. Anyway, the point is that we did this contribution to the documentation. Well, at least it's an issue for now. And then one day, this will probably be merged. And here we'll have this new message explaining that since version 3.12, you can do this kind of thing. Okay, so we were talking about the match function, right? So let's add some cards to the match for the match function. So pathlib, if you don't remember, in the previous two videos, we have created cards for almost everything related to pure paths. We have two things missing from pure paths, the match function and the relative to, and then we will move, to the concrete paths. And concrete paths, if you don't remember, are these paths that are matched to a file in the file system. So they are real paths, and you cannot, or concrete paths, these concrete paths, you cannot create objects of a concrete path for a different operating system that you're in. So you cannot create a Windows concrete path in a POSIX machine. So let's see. So what does this match do? So match basically rematch this path against a provided glob style pattern. And glob, this is an interesting word that I think I will also add a card to. How do you name the pattern matching style, I don't know, of /py these patterns are called globs, and it's also called globbing, right? And what is globbing Unix? You know where this comes from? This comes from a program that was in Unix. This was programmed by Dennis Ritchie, I think, the creator of the C programming language. It has this kind of these patterns. So these are globs, and matching or expanding them is called globbing. I'm not sure if matching is called globbing or expanding is called blowing. I will probably revisit this card later on. How do you name this? There's also slash dot. This is kind of an extension, but you could also do slash dot py this, which I guess would match also. So let's make a test. Okay. This matches any character, but there is some character, right? This is not like a regular expression. Let's keep this way, and we will probably modify this card in the future. So regarding match, how can you check if a file path follows a given glob style pattern, right? This is exactly what this thing does. We could let's from pathlib import your path, and let's do this in a so pure path. I don't know, we can hide this thing, right? So this is true. And then we can have something which is true and which is false. Let's copy just this whole example. Okay, so basically we are hiding how match works. So using the match method. So then more questions about pathlib, match, another path, right? Can you match a path to a pattern is it possible to match one path to another path with a glob style pattern? So what do I mean with this? So we from pathlib import your path, then we say pattern equals pure path asterisk py, and then we say pure path hello.py dot match pattern. And the answer is yes. Yes, this is possible since Python 3.12. In fact, as we found out while creating this deck. Should I add this here or doesn't matter? Let's add another thing here. It is in fact, this is a faster alternative if you match many file paths to the same pattern. Okay, which is what it says here. And what about absolute paths? So if pattern is absolute, the path must be absolute, and the whole path must match. So let's do this with here. Pathlib match absolute. So what is the output of the following code, right? What happened? I think I toggled the beam. And here the output is false. Okay. Now I'm on beam mode. I don't know how to disable it, so I will just keep it. Keep it on. So the thing is, if the pattern is an absolute path, it will only match the absolute paths. Okay. So then we have this thing, and then we have the other thing we need to manage is this case sensitivity. So what about it? So basically what we have here is that for in Windows, it seems this doesn't match, and in Windows it doesn't match because it doesn't care about case insensitive, I guess, extensions. I'm not sure about file names, but this doesn't match here. We can set it to true to override this behavior. I don't honestly know why you would want this, to use this case sensitive thing. I guess you would want it if you want in the Windows side, if you want to be more what's it called, more strict, right? You would set case sensitive equals false. I think that's the only, I don't know why you would want to put a true in the POSIX path case. So we would want a pathlib case sensitivity. So here you would say, okay, let's set it here. So here you do a pure path, a pure Windows path, pure Windows path of a true. Case sensitivity follows platform defaults. Let's look what happens. Windows case sensitive file system. What's the phone? In Windows, the file system treats file and directory names as case insensitive. Foo and foo will be treated as equivalent files. Okay, that's interesting. Linux is definitely case sensitive. It's really honestly not important, I think, to change this behavior, but I think I'll add it just as a comment. you can modify this, the default behavior with the case sensitive parameter, which was added in Python 3.12. So what we're talking about is this thing here. So this is pattern. I don't know why there is this. Okay. Anyway, so I think with this we have covered all of the match functionality. So let's move to the relative to. There is one thing also that I also, again, sooner than later, this is a to-do, but I think I will create a deck of the built-in exceptions. I think this list, which is not very long, I always say this, the same thing, it's not very long, but then it it gets longer. But I think it's useful to have this kind of an example, at least triggering each of these exceptions. So right when the input function hits an end of file condition without reading any data. Interesting. Floating point behavior, error, not currently used. Well, that one we will not add, right? Module not found error. So if you say Python and you import blah, I just created this directory. Module not found error. That's useful. It's useful, I think, to know like what are the exceptions. Okay, let's go back to relative to. So relative to computes a version of this path relative to the path represented by other. And then there's this walk up parameter. So it's easier to understand, I think, with an example than with the description, right? So the question is, you have this path relative to root, it is this one, relative to etc, it is password. And relative to user, it is not relative to user, right? So let's write this down. So this is pathlib relative to. Remember, this is the last one we need to do to cover all of the pure paths. So how can you find the path? How can you find the path to a file from another path or from another directory? Let's play a little bit with this so we have a better understanding of what we're doing. So pure path, if we have a, b, c.py relative to a. So relative to a, we have bc. What if we say /a? Okay, that's not possible. What if we have this and then we have relative to a? That is not possible. It needs to be a subpath, right? If it's /a/a, that works. If it's /b/c, doesn't work. /b works. What if we say walk up equals true? Let's try to have some. Okay, so walk up works in a sense that you can go up and then down, right? So with walk up, you can do more stuff. What if you say from A? Doesn't work, right? They have different anchors. But if you have /a, b, c, d, blah, 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 still it works, right? However, what if this is a a file. Of course, it doesn't matter, right? If it's a file, it doesn't matter. Oh, okay. So other is kind of like a directory, right? Okay, the walk app was added in 3.12, and then it's deprecated. Passing additional position arguments is deprecated. If supplied, they are joined with other. Okay, so adding other is not supported, or will not be supported. So we will not even include that. Okay, so how can you find the path to a file? It's hard to explain what this is doing without saying the word relative, right? How can you find the path relative to another path that is how to get to one path from another one? So the question is, of course, from pathlib import your path. I'm trying to favor creating the cards, and then we might edit the wording in the future. So I think it's better to have just a comprehensive deck of cards with all the things we need to cover, and then we will edit them and improve if necessary. So I'm not super happy with this wording, but we will come back to it another day. So from path import pure path, so let's say pure path slash user bean. What do we have in user bean? We have Python, I think. User bean Python, and then we say p dot relative to, and let's say base equals slash user. So relative to base, we can even run this code, right? So we will going to say this base is user. I guess it could be a path, of course. Relative to base. I hope this could be a pure path too. Yes, it can. So it says bin Python. Okay, so here, this is the thing we want to hide. Okay, so relative path. So pathlib relative to dash walk up. We want to cover this option too, right? Again, this will probably be not important, but is it possible to find a path relative to another one when the other does not start with the same parts? Oh my god, this is terribly worded. Let's add one thing here. Pathlib relative to value error. Right, so what is the output of this command? We could even say have another with the output, which it is correct, because this is not obvious. So what is the output of this command in which you say, you know, a, b, c, d.py, and here you say relative to a, b. So I guess this is cd.py, right? Let's test this thing. So exactly, it's c.py. This is what we're going to hide. And then we can do the same. Like if we are trying to go relative to a, e, then we're going to get a value error, right? So it will say something like this thing here. Which Python? Which Python? Python user bin Python. I want to have a clean. Oh wait, not Python 2. So I want to have like a clean error message. So it has, this one is the one that triggers the error. Okay, so it has this error. Okay, so value error because this command relative to fails if the path p is not not a subdirectory of AE, which is not. Okay, so finally walk up. Is it possible to find the relative path same part? So now this same thing here is the one we want to show. Yes, it is possible using the walk up parameter. So let me copy the whole snippet. So if we say walk up equals true, however, this walk up equals true only works in Python 3.12. So we want to do this in Python 3.12. This kind of thing, it's better to just, know that it exists, which was added in Python 3.12. Okay, so we have this walk up covered. Man, let's hide it here. Okay. So now we have the relative to I think, covered. So we have the relative covered, and we have, let's go to Python cards, to my Git repository, copy cards here, cards, let's commit, completed all the pure path methods. And let's submit this to GitHub. Okay, so now let's have an overview of what the concrete paths have for us. So here the concrete paths. So there's this question that I have thought before. So pathlib path. When using the pathlib module, which is the main class you will use 90% of the time? And the answer is pathlib.path. It is a concrete path class that has a mapping to the real file system, specific for the OS you are running on. Okay, so file system, you might like it as this. I think here it says file system as a single word, so I'm going to do the same thing here. Oh, what's going on? Blah, 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 blah. Okay. Right. So it's good to know what we're doing. So we have all these concrete paths. So maybe somebody is still wondering, what is all this pure path nonsense? So why did we learn all of this pure path nonsense if 90% of the time we're going to use path? Well, path is a subclass of pure path. That means that path implements all of the functions that pure path also implements. So everything, everywhere where we wrote here, pure path, pure path, pure path, pure path, applies to a path. So that's good to know. Also, pathlib path instantiate. Instantiate is a good word. Instantiate is a good word. Let me write it. I have somewhere nomenclature. Let me find if I have instance. No. So instance, okay, but instantiate. So that's a good word to know. That means when you create an object of a class, right? So what is the output of the following command? So from pathlib import path, which is what you're going to do 90% of the time, right? So what is the output of path setup.py? What is the output of this? POSIX path. I think maybe we already created one of these cards for the pure path, but it's always good to it doesn't matter if we repeat one of these. It will be a Windows path if you are running a the Windows operating system. Okay, good. So here we see what happens when you do this. Then if you create a POSIX path, then you are going to do the same. If you create a Windows path, that will fail, of course. If I create from pathlib import Windows path, and I instantiate this Windows path not implemented error. Okay. I think, I'm not sure if we have not implemented error. We already have this. I already created a card for this thing. So no need to do it again. Let's collapse some of this stuff that we added today. We're already getting some good number of cards. Let me copy this thing. Let me grab this thing. 64 cards. Okay, 64 cards, that's good. How many cards should you learn in one day? That's a good question. I'm not sure. I think 5 is like the lower. I think less than 5 doesn't make much sense. If you learn 5 cards per year, it's almost 2,000 cards that we already had. So if you learn these 5 cards a day, 65 divided by 5, it's 13 days. In 13 days, you master the pathlib. If you do it in 10 days, it's 1 week. I mean, 1 week, we still have some cards left. I think between 5 and 10 cards, it's something reasonable. Of course, you need to be, constant. You need to do it every day. We'll see. We'll see when we launch. So we have this thing, methods. Okay, let's go for the methods. Okay, so I think we already have the CWD. We already covered this. So what is the CWD? It's the pathlib, the current working directory. How can you find the current working directory, or usually called CWD? Let's omit that part. So Python from pathlib import path, again, path.cwd. What is my path? This is interesting. There's an interesting thing here. So you get the current working directory, but it returns you a POSIX. Oh, no, sorry. No, it's a POSIX path. I was thinking it was a pure POSIX path. No, this is a real path. So this is the kind of thing that you cannot do because you are, if you're using pure paths. So for this is like a real path, right? What if the home doesn't exist? Well, I guess this one can fail if like the home is missing or something. But anyway, let's see what happens if we export home equals empty and you run Python and you from pathlib import path and you do path.cwd. Okay, it still works. How does get CWD? Oh, because sorry, it's on the home. I mean, I was jumping ahead. Let's from pathlib import path.home. Okay, it's the root directory. That's interesting. Let's close that shell. Okay, so we collapse this thing here, and now we get the home. How can you find the user's home directory? Well, home. Of course, this. Oh, I was confused because I was working in my home directory, right? So projects, Python cards, for example. Okay, let's have some different. Let's have the real one, right? Which is Git. The real one. So the home you get with this, with this construct. Is the home directory, if the home directory can be resolved, this is raised. So this, it could be happen that the, imagine we said the following: export home equals some weird path that doesn't exist. Okay, and now let's run Python from pathlib import path.home. Still it works, but does it exist? No. Okay. It cannot be resolved. I wonder what it means that it cannot be resolved. What does it mean that it cannot be resolved? If we add some spaces, does that work? Still works. I don't know how we can make it not resolvable, but doesn't matter. So here we are. Where are we? Oh, home and current working directory. Okay, so we have a way to find the home, we have a way to find the current working directory. Now let's go for the next things. So here we'll have a list. Let's make a list of all the things that we'll have to, all the methods, right? So this is this is stat chmod, which stat gives you, is it called statistics? I guess. Is it like a man stat? Display the file system status. Okay, status. So it's not statistics, it's a status. So we have the stat chmod, which is for changing the permissions, exists, expand user, which expands this tilde character with the home of the user, then glob, which is very useful, group, is dir, is file, is junction, it's weird Windows thing, then is mount, you're using is symlink, is socket, is FIFO, is block device, is char device, then iterdir, walk, lchmod, lstat, make dir, then open, owner, read bytes, read text, read link. Interestingly, this one doesn't have an underscore, just an underscore because they are different things. Then rename, replace, absolute, resolve, rglob, rmdir, same file, symlink to, hardlink to, touch, and link. I don't know why this is. This was following like alphabetic order, and this one is out of order. I don't know why. I guess because it's just below symlink, but still. And link, which is for deleting, write bytes, write text, and that's all. Okay, so let's sort this by importance. Okay, let's do the more important ones. More important, in my opinion. So stat, these ones are important, somewhat important, not so important. Now we're going to use this later to tag this thing. So is this file, expand user, glob is important, group is kind of important, Is junction is not important. Is mount. Is sibling. Iter very important. Walk, very important. Okay, then make dir is important, of course. Sorry. Open is important. Read bytes. Let's put this one here. Sorry. Read bytes. Let's put it here. Then rename, replace, absolute and resolve are important. Our globe, I think, goes here. Okay, this is like the tier list, right? Touch and link and all those things. So, and the bytes, we're putting them here. Okay. So, I have separated in important, somewhat important, not so important. Okay, so it's good to know how much work we have missing, right? So, pending. So these are the important, somewhat important, not so important. Okay. I think we'll have to at least one card for each of these. Some will require more. So let's get started today with the important ones, and then next day we can continue with this. So the stat is an interesting one. The stat, what is a stat? Let's open this Python. So from pathlib import path, let's open a path which is, you know, the markdown file. Okay, so what is the stat? It is an os.stat result. So from os import stat result. Is that a thing? Yeah. Stat result. What is a stat result? What does a stat result have? And what is man stat? This is an object. Is stat result something? No. So this is a file or file system status. If we, let's split this and let's go to git python cards, and if we stat cards.md again, yeah, it has this. It has the mode. It has the inode where the file is. It has the device, nlink, which I don't know what it is, the user ID, the group ID, the size, the A time, which I guess is the access time, the M time, which is the modified time, and the C time, which is the created time. So, okay, so stat is one that we will have to break in different questions. So, stat return type, let's say. So, what is the return type of path dot stat of a given file, right? Sorry, the path is like this, right? So the file.py dot stat. what type of object does this thing return? And it returns an os.stat result. That's it. So that's what it returns. Then pathlib. So you have the access, modify, and change times. You have the inode. We'll have some questions. How can you find out what inode is a file located in? And the question is, what is an inode, right? Why is my computer in Spanish? I want it in English or in Catalan, but I don't want in Spanish. Okay. So it's a data structure of a Unix style file system describing the file system object such as a file or a directory. Its inode has the attributes of the dislocation of the data, blah, blah, blah. So this is how, what is the etymology? Okay, is this guy, Dennis Ritchie? Oh, he doesn't know. I guess I is index, right? So the inode, let's using path.stat. Dir file.py .stat. The inode index node is a data structure. I guess the inode, stat and inode. What is the file inode information? Each file has an inode containing metadata of the file. Our application can retrieve this metadata using stat or related calls, which return a stat structure, or statx, which is a static. Okay, so inode and stat is kind of like the same. So the stat is getting the inode ID, right? So what you want to have, how can you find the inode let's call it number of a file? You are actually retrieving all of the metadata stored in the inode, including its number. The number is including its ID. It's probably an ID. Okay, so pathlib mtime. How can you find out when a file was last modified? So using with path.stat.mtime. Is that it? So which let's ls no. Oh, that's IPython. So path cards.md, okay, dot stat dot mtime. No, what is the mtime? St mtime. Okay. And let's from pathlib import path. Then path file.txt stat.stm time. And then the output is something like this. So let's copy the snippet here. It helps get some context. Does it help? Because you already know that you need to use the path. I think it's better not to know that you're using the path. So then we have the access time. Access time? Do we want to say read? Read? What's last read? So that way we don't have the word access and we don't give a hint about this. And then we have the C time, right? When it was created. Okay, so the access time is this one here. Let's be faithful. And the C time is this one here. Oh, wait. What is the C time? Okay, no. Last access, last modification, last status change. Okay, so what is that? I clearly don't know what I'm talking about. C time status change. What is stat C time? What does status mean? Linux, what is a file status change? Okay. This is what we want to know. Modify is the timestamp of the last time the file's content was modified. Change is the timestamp of the last time the file's inode has been changed. Okay. Okay, so the last. How can you find out when a file's content was last modified? Okay. How can you find when a file's status was last modified? Or file's inode was last modified? For example, by changing its permissions, moving permissions, file name, owner, etc. So it is the C time. Where C means change. Okay, so that's good that we learned about this because I clearly didn't know. So stat is important. Stat is important. What else do we have in stat? So stat, number of links, user. I mean, all of this. Now we're talking about stat. We're not talking about. So maybe we're going like too far, but doesn't matter. So it's the stat dot stuid and so on. Like this is a very, very important data structure for any Unix kind of system. And I guess something very similar must exist in Windows. So pathlib. Oh, this is not. Okay. Stat UID. How can you find out a file's owner user ID? Yeah, I mean, this is important. It seems redundant since we're doing too much work, but this is the kind of things you need to learn, right? So if you want to know what is the user, you do it this way. So stat UID, the output 1000 with stat UID. Okay. And the group ID. Files. How do you find out the files group ID? Well, with GID. $1,000. Okay. User ID, group ID. What else do we have? What else do we have in the stat? So we have the mode. What is the mode? I mean, this is more of a stat result stuff, right? File type and file mode bits permissions. Group ID, size, access. Oh, here you have the explanation. So C time, change expressed in seconds. Birth time. What is birth time? It doesn't have. It's probably depends on the file system. You might have it or not. So, I mean, there's many more things, but I think we are going to stay with these things. And there's the hard links, and there's other stuff, but I think this is enough. Okay. So we got one of the most important functions, right? Okay, so how can you change? So ch mode. How can you change a file's permissions? So for example, you would do from pathlib import path, then you would do path keep file save.txt or pathing or p equals, let's call this secrets.txt, and you want to set it to 400, right? So you only you need to learn about Unix permissions, right? But it has 3 numbers. Each of them has 3 bits. So it goes from 0 to 7. So 3 bits, 2 to the 3rd power is 8. So it can be either 0, 1, 2, 3, 4, 5, 6, 7. And the 3 bits are permissions for the owner, the user that is the owner. Second bit is for the group. Third bit is for the for any other user, right? So users in the same group or users from another group. And then you have 3 numbers. First is read, second is write, third is execute. So that's how you manage permissions. I mean, Unix permissions calculator. What is this calculator? Okay, so the owner, the group, and the public. So for example, if I want to keep this file secret, I want the owner to be able to read it, and that's all. So not even write it. So here, what we can do is chmod, and we would do that. Okay, but careful, because it seems that's not how it works. So let's touch blah.txt. So we have this blah ls minus l blah.txt. It has these permissions. It is not. Oh yeah, here it is. Read, write, read, write, read. Okay, so let's take path blah.txt, change mod, and let's do it 400. Okay, that doesn't work. It needs to be an integer. So it needs to be an integer means that it should be. This is, I guess, what is this? 0, 0. Is this like octal? Okay, now it's read, blah, blah, blah. So Python integer 0, 0. Octal number. So octal numbers are from 0 to 7. What happens if we said, 400? Oh, it doesn't work. Why? Because this number in octal is something different. So this is a very, very important caveat. And this is like very nice of Python, but let's say, what is the output of the following command? So it's important that this needs to be in octal. So, or let's do 644, right? Which is another typical permission. And this is like completely wrong. Completely wrong. However, if we say 0 of this, then that's what you expect. Read, write, read, read. Okay? Or 664, which is another typical permission. So pathlib, chmod, decimal. What is wrong with the following? I think this is an interesting card that we could put on the landing page. So I don't know, code.py, and we want to make 644, or even you may want to make it 755, which is that you can run this thing, right? So you call it. Oh, this is not a string. Sorry for that. So we were working on the chmod and creating this question of what is wrong with this command, right? So the problem with this command, of course, is that the argument for chmod needs to be an octal number. Is that what it's called? Which in Python is represented by 00755. So you would do e.chmod 00755. So just quick reminder, what does octal mean? What does 0, So in octal, which is base 8, you have 8 numbers, which are 0, 1, 2, 3, 4, 5, 6, and 7, right? So you specify those with this 0, 0. If we check this here, well, this is how this is done. We have this follow sim links, which is part of almost all functions. We'll have a separate card to do have a card for follow siblings. Okay. So we have what is the output of the following command, which is an error. What is the output? Well, you get a type error. You got a type error because the mode in chmod mode needs to be integer. Even more, we usually would represent that integer as an octal. Let's see if I can find here the name octal around here, or no. It is not even. What's it called? Octal base. Yeah, this is good, but I want it in English. Octal or oct base 8. Okay. Base 8. So as an with that integer as an octal in octal. Okay, so it is 00400. So we have this thing here. What is the current? So the question here, this is the Python specific stuff, right? So here we check what is the output. Okay, this cannot be a string. Then what happens if we have a decimal? Well, it should be octal. But then the question is, how did we want to go into understanding the permission system in Unix, right, or in an operating system? So we could have, and of course, this is like the real thing that operating with paths is about, right? We spent some time talking about stat, but yeah, stat. So this is pathlib, right? We need to manage paths, we need to manage files, and that means managing permissions, inodes, statuses of these these things. Oh, I think we also read somewhere that stat is status, right? So pathlib stat meaning. So what does stat in path dot stat or path dot stat sorry, pathlib stat meaning. What does stat in pathlib, path.stat min. And this is the man stat. Stat is short for status, as in file or file system status. That is what stat is. So regarding chmod, so we don't need to understand, like we don't need to fully explain what chmod is and how you set all these permissions and so on. Because if you're using, what we need to teach how to use chmod in Python, right? So here we know how to use chmod. Let's have one more that hints at what you need to know to really understand chmod. So how do you set the permissions of a file? So let's make a list. So the owner can read, write, and execute it. The group, the users in the group can read and execute it. Any other user cannot read it or execute. Either user can only read it. Something like that. So basically, from pathlib import path, then p equals path dot file.txt. Now what do you do? So you do p.chmod. So read, write, execute is 7, read and execute is 5, only read is 4. So that's what you do, if I'm not mistaken. So let's do this. Let's try this 00754. And if we list it, it's read, write, execute, read, execute, read. Okay. So let's put 755. Sorry, 754 stands for. So 7 is 111, which allows read, write, execute. 5 is 101, which allows read and execute. 4 is 100, which allows read. Okay, let's leave it here for today. We have spent some time, but this is like the meat of the pathlib, is managing files. Before we were using all of these files that are this pure path methods and functions, which they are useful for. I don't know what is this here. So these are the methods for manipulating the paths and so on, which is fine, but it is not like super interesting. And now we're starting to manage all of the real path functions. So what are paths about, or what are files about? Where in the file system you want to know if they exist, you want to move them around, delete them, rename them, check their permissions, change their permissions, check the owner, check the group. So these are like the read, write, link. These are all the things that you can do with a file system. It's interesting if you understand some of the history. This guy, John Ousterhout, who is a very famous professor on Stanford, he wrote the Tcl programming language, and he has done some very, very good contributions to computers. He talks about how the Unix abstraction of file systems is one of the ones he loves the most, and he thinks is one of the best abstractions ever in the history of computers and operating systems, because it's hard to believe nowadays how in the past all of this wasn't abstracted away. So all of this was about specific drives, specific hardware, managing files and managing how things were, data was written and read and so on, and having this abstraction was a huge benefit. So here is where we are starting to get the real power of the file system, and we will continue the next day with more pathlib. See you next time.